Hi, everyone, and welcome to this week's Cribl weekly demo, Parse logs and aggregate into metrics. Before we jump in, I just wanted to take the time to introduce myself to those of you that I haven't met. I am Desi Gavis-Houston, and I'm the Sales Development and Sales Enablement Lead here at Cribl. Previously, I led the National Sales Development Team at co-working company Industrious, and before that, I was on the sales team at ad sales enablement company Media Radar. I also built the sales development team at Trello. So my path to Cribl is a little non-traditional for sure. And I've been in a few different industries in my career. Ultimately, though, it was a no-brainer for me to come to Cribl because I love and I'm good at matching people with tools that give them more flexibility and choice in their business. And ultimately, that's what LogStream provides. That's what we're doing here. So lovely to meet y'all. Here's what to expect on today's call. So almost every week, some holidays excluded, we'll be doing a demo of Cribl LogStream and walking through specific use cases in the product. So first, I'll do a quick introduction to observability pipelines and LogStream for those of you who may not be as familiar with us or what we do. And then from there, we'll move into a full demo of LogStream. We'll talk through the specific use case for that week. Obviously, this week, that's going to be using LogStream to compress logs into metrics. And then you'll have the opportunity to ask some questions regarding the product or anything that you've heard or seen today. So global data is growing at a 25% compounded annual growth rate. And I think everyone in the world understands this to a degree. So take being in a global pandemic, for example, rather than our business meetings happening in person, they're happening here on Zoom, and Zoom's generating data. So even if you think about it from a non-technical perspective, it's easy to see data is growing astronomically. By 2025, enterprises are going to be managing 250% more data than they were in 2020. So the amount of data is growing, but there's another problem. Logging systems are already at capacity. I talk to enterprises daily with costs in the millions when it comes to licensing. Secondly, the infrastructure required to store that growing set of data can cost either as much or more than commercial licensing costs. More data obviously also means you need more CPU dedicated to analyzing it. And for many customers, the added infrastructure costs can be in the tens of millions of dollars. On top of all that, you get inadequate data retention in some organizations, right? When your logging system is reaching its limits, a lot of people really believe they have no choice when it comes to dropping data that they'd ultimately like to keep around. So to get the answers that you need out of your environment, you need to onboard new sources of data. There's just no way around it. A lot of companies will drop large portions of high volume sources just because it's too cumbersome and costly to analyze everything. You may also have retention policies in place to meet certain standards and regulations, but you're having to guess, right? How long can I afford to keep a wider set of data around? And you may even need to revisit that data later, especially if you're investigating a security breach or trying to understand long-term trends in your IT environment. For some use cases, keeping data on hand to analyze for years may be required. It all depends on what industry you're in and just your business requirements in general. And then lastly, systems are optimized to handle data analysis and data retention separately. So what that means is you often end up using many different tools to retain and analyze all of your machine data. Adding each one of those tools also adds complexity and hidden costs. So, like I just mentioned, environments are getting super complex. You've got your object storage, your time series databases, your data lake houses, and each of those have their own agents and their own ingestion pipelines. It gets really tough to manage it all. And it just forces enterprises to make some really hard choices about which data to send to where. And those choices typically mean trade-offs. You really end up playing this three-way tug of war with cost, flexibility, and visibility. The more data you analyze, the longer you retain it, the more it costs you. Standardizing on a single tool limits flexibility, and dropping data to keep costs down could limit what you can learn or investigate over time. So how do you do it, right? How do you manage the trade-offs of analyzing everything you need to get insights from your machine data, formatted for all the tools you use without busting your budget? An observability pipeline solves all of these problems. And our product, Cribl LogStream, helps teams to implement an observability pipeline without replacing any existing tooling. Cribl LogStream does several things. It enables customers to choose what data they want to keep, in what format, and in which data store, all while providing the assurance, right, that you can also choose to delay any or all of those decisions because you have a full fidelity copy and low cost storage. And we enable you to do that. LogStream also provides customers with a vendor agnostic solution to route data to and from any tooling source or destination. So regardless of which tools you're using, LogStream can centralize the forwarding of all of that machine data, get it to the right destination, ensure it's shaped, enriched, ready for analysis, or just like on standby for when it might be needed in the future. And then the last thing here, LogStream significantly decreases an organization's logging and monitoring costs. On average, we see customers saving about 30% of their infrastructure costs when they use Cribl LogStream. So one question that may be popping up for you is, Desi, doesn't data streaming already exist? Yes, and the data streaming solutions that do exist are not purpose-built for polystructured data. On the other hand, an observability pipeline is purpose-built to work with even the most complicated data formats. So the data that you need probably exists in multiple sources, right? With different protocols that dictate how that data is generated and collected. You've likely got data coming in a variety of formats. They may not always match the formats required by the tools that you actually use. So that can be a huge problem. And then you probably have come across some streaming solutions that just couldn't scale with your business requirements. Cribl LogStream can. We've tested it at over 20 petabytes of data a day. So if you remember nothing else I've said today, please remember this. Cribl helps implement an observability pipeline to route security and machine data where it has the most value. We help you slash costs. We're going to improve performance. Get the right data where it's needed in the formats required. And with LogStream, you can reshape, reduce, or route data so that you remain compliant and get the insights you need in the most cost-effective way possible. So next, I want you to see the product. My colleague, Matthew Pike from our solutions engineering team has graciously, thank you, Matthew, if you're on the call, recorded a full walkthrough of some of the key use cases of LogStream. So let's take a look at that now.
All right, we'll click on our worker groups and we'll go into our logs worker group. Now here you can see our list of routes, 1 through 12. The ordering of the routes matter because as an event comes in, it's processed from the top to the bottom, kind of like a firewall rule set. So we'll expand one here to take a look at it in a bit more detail. We have the route name, Palo Alto Firewall Traffic. We have the filter. In this case, it's matching source type to PAN traffic. The name of the pipeline that we're going to be using, the output destination, description, and the final flag. So what the final flag is for is if it's set to yes, that means the event, once it matches this particular filter, is sent down the pipeline for processing, but the event doesn't continue on to the rest of the routes, 3 through 12. If the final flag is set to no, then a clone of the event is sent down this particular pipeline, and then the original event continues on for further processing. All right, let's talk for a moment about the filter expression. The filter expression is a JavaScript expression, so you can be as complex as you need to be. So long as the end result, it evaluates to true or false, then the route knows how to handle that particular event. So if it's true, it goes down this pipeline. If false, it goes down and is continued to be processed. All right, let's look at another route real quick. In this case, it's the archival route. The filter expression is set to true, which means match everything. The pipeline is a pass-through pipeline. It literally does nothing. And it's sent to S3 for a destination. and S3 is cheap mass storage. So it's pennies on a dollar to save something to S3 versus, say, into Splunk. Now, any event that reaches this particular route is backed up, cloned to S3. You might recall our Palo Alto firewall here was a final flag set to yes. So this means the event isn't actually reaching the archival route in this instance. So we can fix that pretty easily. We can just grab this route, drag it above the other one, and click Save. And now the Palo Alto events are also getting cloned to S3. So we've got a full fidelity copy of everything sent to S3 for, again, cheap storage. Next, we'll dig into a particular pipeline and go into it in some detail here. Expand trim big JSON. And we can see the filter expression is index equals Cribl and source type equals lambda. And the pipeline itself is trim underscore JSON. All right, so we can see this particular pipeline uses two functions, a comment and a parser. It's always a really good idea to include a comment at the start of your pipeline with who created the pipeline and what the expected outcome was, and any other details you think would be pertinent. All right, we're going to start with a capture. And we can see here the filter expression was carried down from the route we clicked on the pipeline from. And when we click capture, we can choose how many seconds or how many events. We'll leave it as default for 10 and 10. And it's pulling these events off the wire. And now we're going to click Save as Sample File, and this saves it to a sandbox file we can try out different scenarios on without impacting our production data. Once we click Save Sample File, we open the sample in our preview pane here, so we can take a look at the data. So as we look at the JSON object, we can see a couple things. We've got headers, 20 items, multi-value headers, 20 items. So these are in fact duplicate fields with duplicate data. So we can get rid of one of those and save some space. Also, we have fields that have no value, so they're providing no benefit to us. We're just using up system resources by sending the field name down with no actual value to it. So we use a parser function to make some changes here. We're going to do a reserialize on the JSON object. So we're opening the object, making changes, and then wrapping it back up. And we can work against a few different types here. We've got delimited values, key value pairs, common and extended log file formats, and CSV. We're going to be making our changes to the underscore raw field. We're going to be getting rid of multi-value headers, and just because I'm not particularly fond of it, we're getting rid of the request context as well. And we can see here in the fields filter expression, value not equal to null. So this is saying only keep fields that have a value. So now we can click on out and see the end results here. We see that green is something that's been added new, orange is something that's been modified, and then red is something that's been removed. So we see here multi-value headers. We got rid of the duplicate headers, we got rid of these null fields, and we got rid of the request context. So what does this mean to us in practical terms? We can look at our statistics here and see a 65% reduction in the size of the event. Pretty significant savings. That's great. Okay. Now, I just got a text from my boss, and he absolutely loves the request context field, so he wants me to add it back. So we can just click X, click Save, and we see that it's added right back. So what does that mean to our statistics now? Still a 45% reduction. Still pretty great. And this isn't, just a reduction in this event. It's less data going across the wire, less data being processed by your system of analysis, less disk space being used, etc. So you see a savings all the way down. This is just one of several ways we can help reduce data going into your system of analysis. This one works on the fields of an actual event, but we can also drop events as well. Let me just explain a couple of those real quick. So we have drop. The drop function will drop anything that matches the filter. So perhaps you have the word debug in the comment. We can get rid of any event that matches that. And we've got suppress. Suppress is a function for volume reduction by volume over time. So say I'm getting 100 events in a minute that tells me everything is okay. We might just want 1 or 5 instead. So we can do that with suppress. Then we have sampling. Works against a particular data set. Say you want to keep 1 out of every 5 or 10 and let those through and drop the rest. And finally, we have dynamic sampling. Dynamic sampling is an algorithmic way of saying if a particular type of event is low in volume, keep all of them. But as it reaches a certain threshold, get more aggressive in dropping them. So there's a few other ways we can make some savings on your system of analysis. And there's a number of different functions you can use to build pretty complex pipelines. All right, next let's look at some enrichment using a different pipeline. So we'll go back to our routes. And this time we'll be working on the firewall GeoIP enrich pipeline for the Palo Alto firewall traffic route. So click on the pipeline. You can see in this one we've got some function groups. So we've got 1 through 5 does some extraction and reduction. And so you can kind of create these groupings of functions to make it easier to understand what a particular group of functions is doing. Again, you should always have your comments in there to make it clear when you come back to troubleshoot later what it is you were trying to do. In this example, we're going to be using a previously defined capture file. So we'll pull that up. We can see there's a lot of different fields, comma-separated values in this logging data. So we'll want to extract those fields out of the CSV and put them in the body of the event and pull them out of raw and get a clear list of all of the fields and what their values are. So we can use a parser function to do that. And it'll pull out all of these various field types and then put them into the body of the event. So we can click on out to see the end results of that. Now this is going to make your event size bigger. You probably wouldn't do this in a real environment. For the purposes of demoing what you can clearly do with the parser function and building up these fields is why we're doing this way. So you can see now we've got all those fields nicely in there. And we can dig a bit deeper. All right, let's look at a way we can add some enrichment to your data. We're going to do a GeoIP function. GeoIP does a lookup against a MaxMind GeoLite 2 city database. MaxMind is the company in charge of keeping the mapping of geospatial information to IP address. We're going to look at source IP and destination IP. And to do this lookup, it needs to be an internet routable address, obviously. So we've got our destination IP address here, which is internet routable. And we can see here the city name is Boardman, Oregon. It's beneficial to do this type of enrichment at the time the event passes through LogStream before it goes into your system of analysis. That way, if you need to look back due to a security event of some kind, you know exactly what the mapping was at the time the event happened, rather than enriching it later when you're doing the analysis of a previous event. All right, so there's a few other ways we can enrich our data, and we'll look at one of those next. Another really cool one we can look at is eval function. And here we've got a field that we're going to add, and the value that we're adding is the result of this JavaScript expression here. So let's pop out the tool and take a look at it. So what we're doing is we've got a file of compromised IP addresses. This might be from the internet where you have a real-time blacklist, but we can do this sort of lookup on any type of data. So we're doing a lookup that says match the source IP address or match the destination IP address and either return true or false. And then we're going to be assigning that value when it comes back to the compromised field. So we can see over here, compromised false. So this particular host for this particular event has not been compromised. All right, so we have one more thing to show you here. We're going to be using a different route for this, and this is going to be looking at sensitive data. I just really want to show you really quickly what types of masking we can do. So we're going to look at the masking pipeline here. And we will expand that, and then we're going to load the sensitive data sample. All right, so this is really neat. This gets into one of the other tools that I think is really, really cool. So this is a masking rule tool. We have the regular expression match that we want to mask, and then the function, again, JavaScript, that we're going to execute to produce the value. So let's look at the pop-out for that tool. All right, so in this instance, we've got a social security number. So what we're doing is we've got two capture groups. One is just social equals. The other one is the actual social address, the G2. So we're doing an MD5 hash on the social security and then returning it with the same length as the original social security. So we can see here, we've got it MD5 hashed. This is pretty cool. Another one to look at is encryption. For this particular example, we're doing an ESN number. So similar with the capture groups. In this instance, as I said, we're going to be encrypting it and then adding it back in to the ESN. Now, what's cool about this is if you install the LogStream app for Splunk, when this gets sent over onto the Splunk side, you're able to decrypt it in Splunk, and you can set access controls on it and limit who can have access to the decrypted information. So really, really cool. And this one last one here is looking for a number that is a credit card number. So we are pulling out any number that's between 14 and 16 digits. And then we're running a little helper tool against it to determine, is it a credit card? If so, mask it and return it. Otherwise, return it unchanged. So we can see here we've got an order number and a credit card number. And the order number is left alone and the credit card number is hashed. So pretty cool. All right. So that is everything I wanted to show you as part of LogStream itself.
So you guys just saw a few general use cases of Cribl LogStream. Hopefully that's got some gears turning for you around how LogStream can help you optimize your data. So let's get a little more specific. So I mentioned that you can reduce data with LogStream while remaining compliant. Kind of sounds like an oxymoron, I know, but if you think about it, many of the highest volume data sources come from having to ingest extra info just to access a single useful statistic, right? Just to access one metric. Things like web activity logs, NetFlow, application telemetry, these are all great examples of this type of event. And one way to realize significant savings in your analysis tool, Splunk, for example, is to aggregate logs like that into summary metrics. So because a metric usually just contains a name, a value, probably a timestamp, one or more dimensions representing some metadata about that metric, they tend to require a lot less horsepower and infrastructure to store than log files. So LogStream gives administrators the power to extract any fields of interest using built-in Redis extract or parser functions, and then publish that result to metrics. So once everything's aggregated, administrators are going to see a major reduction in event counts and data volume, and then they can choose whether to send those metrics to Splunk or another system of analysis, or potentially even route the metrics instead to a dedicated time series database like InfluxDB or Datadog for efficient storage and retrieval. So next, we will walk through how to use Cribl LogStream to parse logs and aggregate them into metrics, ultimately enabling your team to free up licensing capacity. So here's another video from Matthew to show you how that's done.
The statistical data you care about whether from logs or app telemetry, and convert them to metrics for downstream analysis. Metrics can help streamline your data, realizing a savings of both license and system resources, while making them faster to process. I'll show you how to do this using LogStream and built-in functions to parse and aggregate for big reduction in the number and size of events. So let's get started. Let's go into our worker groups and logs worker group, and we'll open up logs to metrics. Here you can see the route name and the JavaScript filter expression. In this case, it's using a global variable, and we can see what that global variable is set to by looking in our knowledge objects. Down here to global variables, open up this guy, and we can see the JavaScript value is index equals Cribl and source type equals access underscore combined. So that's what it's going to be filtering on for the route. Just to show you the flexibility of LogStream and how we use JavaScript throughout the product. All right, so open up logs to metrics again. Now we can see it's going to a Splunk metric store as the final destination. So let's take a look at the pipeline itself. All right, here we have our logs to metrics pipeline pulled up. First thing I'm going to do is turn off all these functions so we can turn them on one at a time when we have our sample data pulled up and see the impact of each change. This is a great way to visualize the culmination of each of the functions operation on the data that you're looking at. All right, I'm going to pull up the logs to metrics sample file here. And you can see this is Apache common log format. Lots of interesting data in here that we're going to pull out and add as fields into the main event, and then we'll do some operations on that. To do that, we're going to start with a parser function. We're going to do an extract, and again, in the common log format. So we're going to be extracting the data out of here. We're providing a list of fields that we want to add to the main body of the event. And let's turn this on and we can see the change. All right. So now you can see we've got some really interesting data that we're going to be able to work with here. Bytes, status, time taken, the query key value pair. So some interesting things we can do. Let's look at the next function. All right, so this parser is going to now extract key value pairs from one of the fields that we just created. So we're going to be looking at the request URI query, which is right here. What we want to do is get this JSession ID created as a field and assign the ID to it. All right, so let's turn this on. All right, cool. Here we can see we created a new field JSession ID, and as I said, we've got the session ID now. That is so cool. I just love parser functions because I'm a dork. All right. Next is Numerify. So if you see here, we've got the status 200, it's an alpha. Time taken, an alpha. Bytes is an alpha. So we want those to be numeric so we can run aggregations on it for our metrics. Numerify, it just literally takes any field that has a pure number in it and makes it numeric. Let's turn this on. All right, now you can see here, bytes is now a numeric, status is a numeric, time taken is a numeric. So the last two functions here are aggregation and then Prometheus publisher. So let's look at the aggregation first. All right, so we're going to do a series of calculations based on the fields that we converted to numbers. So time taken and bytes. And as you can see, we have a lot of advanced functionality in the aggregation function. So it's pretty powerful. So when you're doing aggregation, you want to do a group by. So here's the fields that we're going to be grouping by, and everything else is left as default. So let's turn this on. All right, So now, because we are doing aggregations, we've started to see events disappear here. So let's scroll down. Insert elevator music here. Okay, here we go. All right. So now you can see the event type has been converted to a metric. And you can see we've got all these great metrics in here we can send to a metric store and have really fast access to this data. And as you recall, the output destination for this particular pipeline was Splunk metrics. But also, we're going to do something pretty cool. LogStream is able to take these metrics and publish them as a Prometheus endpoint. And turn this on. Now we won't see any change on the right, but now if you have a Prometheus set up, you can scrape against the workers at a particular URL and pull those metrics in to be further computated on in like a Prometheus. So pretty cool. As you can see, this is very powerful, but let's see what the impact on our data was. So the raw length is down 99.65%, which is wicked awesome. The number of events is down 34%. Obviously, we've added several fields, but they are metrics fields, so they're handled a bit differently in Splunk as far as license usage. So I hope you enjoyed this. This is a really fun one for me, and I think it's really a great way to see another powerful feature of LogStream. Thank you very much, and have a great day.
Great. And that's that. At this time, I am more than happy to take any questions that you guys have. Please use the Q&A feature here in Zoom to do that now. I do see one question here, so I'll answer that and then give you guys time to ask any other questions. So this person asked, are there any disadvantages to doing this or to a metrics first approach? This is a really great question, actually. So gathering of metrics provides you with essentially baseline telemetry data that's going to tell you about essentially the health of the various components of your systems, right? How are your applications doing? How are your sensors doing? So these metrics are also going to point out when you begin to deviate from the norm, what parts of the system are impacted, and just give you some valuable metadata just to give color to that visual representation of the metrics themselves, those graphs that you'll see. At some point, though, that count of errors or deviation against a norm isn't quite enough. You need to see the actual log details in order to diagnose the issue. So if I had to answer this, I would say one key disadvantage is that you can't use metrics alone to get by. But as someone who operates a large number of applications, sensors, or systems, right, as an administrator, you also shouldn't have to guess at where and when to look for problems, which is what's going to happen if you only use logs. You also should need to open another separate tool to get that sort of detail. So big disadvantage is you can't use metrics alone, but it does kind of give you a spotlight and tell you where to look more closely at the logs that you have. Awesome. I do not see any other questions coming through. So if that is all, I will end a little bit early. If you have any other questions, feel free to reach out to me directly. I am just Desi, D-E-S-I, at Cribl.io. Happy to answer any questions that you have about Cribl, about LogStream, or just chat. Thank you guys so much for coming. I will see you next Wednesday at the same time.